We will wait for a few more minutes and then we'll start. Okay, I think Mr. Jitendra Kumar is joined. So, Mr. Jitendra Kumar, I welcome you in this live interaction. Can you hear me? I'm audible. Okay, this is the live session. So this is for interaction with the learners, the participants. So I can see Mr. Jitendra Kumar has joined the meeting. So Mr. Kumar, if you have any question or any confusions, you can ask me directly or you can write in the chat box. Okay, so your question is, please explain an example of an autocyclic process. So that you have written over here in the chat box. So first of all, autocyclic process, as I discussed in our lecture also, that autocyclic process is those processes which are confined within the basin. So within the basin, different processes goes on, and those processes are not controlled by the external factors. Directly, they are not controlled by the external factors. So a simple example, within a river, as the river current is flowing through the channel, along the bank of the river, say for example, if it is a meandering river, so there we can see that point bars are formed. So in those point bars, the distribution of the sediment pattern, their accumulation pattern, their gradual growth is controlled entirely by the channel, the flow which is going on through the channel. So definitely no other factor like say major tectonic process or some sea level change or maybe some major climatic change, they are not going to control about the position of these point bars, where they will form, how they will migrate. This is entirely controlled by the river channel, its energy, how much is the flow going on, and what kind of sediments are transported and how they are getting deposited. So this is one example of autocyclic process where the process is entirely within the basin. Similar kind of example we can take from any other environment. Say in the course in my lecture, I explained about the delta lobe switching. So in case of a delta, at the mouth bar area, we get multiple mouth bars at the junction of the delta plane and the delta front. And the position of those mouth bars, they goes on changing with supply of sediments, with energy condition of the river, with reworking by uh, the waves and tides which are going on in the marine system. So all these factors together controls that where the delta mouth bars are forming, and together the overall delta lobe, how they will form. I can just try to make a drawing just to explain this. Just give me 1 second. I hope you can see the slide now. So, for example, if you have a delta, I think you can see the drawing. So, if this is the river system, and maybe this is the uh, sea or the ocean where this river system is coming up. So it will form the delta lobe like this. So maybe one lobe is formed like this, maybe the another lobe is formed like this with time, and they will gradually shift their positions with time. So what will happen? These lobes are actually controlled by the position of the delta plane, which is the river dominated part, followed by the mouth bar, and then the delta front, which comes down like this. So this is the section of a delta. This is the section of a delta. So this distribution of the delta lobe, these distributions, these are entirely controlled by the river channel, how much the flow is going on, what is the energy of the flow, how much is the sediment is carried. Those sediments are distributed over here in the form of delta plane, delta front, and pro-delta deposits. And accordingly, what is the position of this delta lobe, which will change with time depending on the wave activity is going on over here. Associated with that, we have the longshore currents, we have the rip currents, and also we have the tidal currents. So these factors together controls what will be the position of the delta lobe and how it is switching with time. So when this kind of delta lobe switching is going on, there is no external factor is contributing to this. So for example, tectonics, say for example, climatic conditions, they are not contributing to this particular process. So again, delta lobe switching is completely autocyclic process. This is another example of autocyclic process. So I think that it is clear to you. Okay, so Mr. Kumar, I think it is clear to you. You can unmute your mic and you can straightway interact with me. You don't have to write everything. You can straightway interact with me. So if this part is okay with you, you can, if first of all, if this is okay, then fine. Okay, thank you. And so I hope you are enjoying the course. So any queries, any kind of clarification, any confusion? Okay, so I got another question that, sir, can you please explain nested architecture? Okay, again, I would like to share my screen to explain this one. Thank you for this question. Okay, I hope the screen is visible to you. Okay, so in case of nested architecture, first we have to understand about the base level curve. We have to consider the base level curve. And since now already we are into the fifth week, already we have introduced the base level curve and associated system tracks. That part already we have introduced. So I can explain that to you with respect to that particular aspect. Say for example, if you have a base level curve like this, and say approximately the time involved over here is say around 10 million year from here to here. This is the 10 million year time involved for this fluctuation. So if I take this particular fluctuation within this, starting from this phase of rise, to this next phase of rise. I can consider this as one complete cycle. So within that complete cycle, I can get, say, one phase of, say, first of all, LST, the low stand system strat, or simple a normal regression, followed by a transgression, followed by another normal regression, followed by a forced regression, right? This forced regression will continue up to this. And again, we'll get a normal regression. So when I'm talking about these normal regressions, they are actually representing the system strat as per definition of system strat, because they will accumulate all the depositional systems during a particular phase of shoreline set. So during this normal regression, if I talk about this normal regression, so I'll get some depositional systems together. So that will produce one system strat, which we call as the low stand system strat. Similarly, this part is the falling stage system strat. This part is the high stand system strat, and this is the transgressive system strat that we already know. Now this is happening in terms of, say, 10 million year, or maybe a little bit less than 10 million year. So if I now refer back to that orders of cyclicities, time involved over there, so maybe this is indicating a third order cyclicity as per the time involved. Now within this third order cycle, the base level curve of this third order is like this. Now within that, we can have a further fluctuation of the base level like this. That means within this one cycle of base level change, what we are getting now, multiple fluctuations of shorter durations. So maybe this 10 million year, now it is individual fluctuation starting from one rise to the next rise. It is, say, around 2 million years, maybe even less than. So within this 2 million year, if I just look at this particular part, if I that zoom in this one, so again I am getting a base level curve like this, and again within that I'll get system strats as per our normal definitions. So again TST, HST, FSST, LST, and it will go on like this. But definitely now this FSST, this TST, this LST, this HST, they will be constituting the part of this particular curve which is constituting within, say, 1 million year. So definitely the duration of the system strats are much lesser. So they are together constituting the fourth order cyclicity or fourth order sequence. And accordingly, the system strat within this fourth order sequence, they are the fourth order system strats. And in that way, it will go on. So when I'm talking about the third order cycle, it is the part of the base level curve, part of the base level fluctuation, constituting its own characteristic system strats. Now within this, again we are looking at further fluctuation, the interfluctuation of the base level curve. So there also base level will be rising and falling, and within that rising and falling phase, we'll again identify TST, HST, LST, FSST within that particular part. So they are the fourth order. So it is coming into this nested part. So we are starting with, say, if I come from the bottom part, so we can start with some fifth order curve. So within this fifth order curve, we can identify stratal stacking pattern, and those stratal stacking pattern will lead to the system strats of fifth order. So multiple system strats of fifth order will lead to the sequence of fifth order. Now definitely when I'm looking at, say, if this is the fifth order, so definitely this is already a part of the large scale fluctuation of the base level, which may be of fourth order. Actually this fifth order sequence, they are becoming part of the fourth order sequence in terms of part of the system strats of the fourth order, because maybe this part is part of the transgression of fourth order. So multiple such system strats of fourth order together will constitute the sequence of fourth order. And again, it will continue into the third order, and it will go on like this. So for each and every level, we can define the sequence based on the base level curve, and within that base level curve, based on that nature of the base level curve, we can define characteristic system strat of that order. They will constitute that particular sequence. So this is the concept of nested architecture. So I think if this is clear, you can tell me, or otherwise I can also explain further. Okay, thank you, Mr. Kumar. So you have one more question. Can you please explain if we want to construct lithologs for sequence stratigraphy, the points on which we should focus on during our fieldwork? Okay, this is a very good question. This is a very fundamental question. So basically, when we try to do sequence stratigraphy work, it, it is not in the field that we start this particular work. So in the field, it starts with the phasis analysis, which is the base of all these works. So when in the field we are getting a succession, a rock section, outcrop section available to us, there straightway we can identify the different phasis types and we try to put them in the log. So standing in the field, we do not try to log a system strat or a sequence, the entire sequence. We never try to do that. It is not possible actually. So what we try to do, we start from the very basic, which is actually identifying the individual phases and putting them into the log, recording the required data, and then finally in the lab, coming back to the lab, putting them in vertical sedimentary logs from individual outcrop sections. Now, when you get a significant amount of section available to you, then based on those sections, we can go for correlation, and those correlations will give us idea about the phases associations occurring laterally, spatially, and vertically. And those arrangement of the phases associations in 3 dimension gives us idea about the depositional system. So for getting the idea of depositional system, we have to look into much larger scale. Say, for example, in your area, there are 10 outcrop sections. So to get idea about all the depositional systems, you have to cover up all these 10 outcrops. From all these 10 outcrops, you have to make vertical sedimentary logs, and then you have to correlate them. That correlation will give you the spatial and temporal, that means lateral distribution and the vertical distribution of the phases types and the depositional systems, which is the base for system. So just by constructing one single log from the field is not sufficient enough to interpret about the sequence model or sequence study. So coming back to your question now, so if we want to construct a litholog for sequence stratigraphy, first of all, a single log will not be sufficient enough to do sequence stratigraphy work from one outcrop section. We have to get multiple logs, and standing in the field, you cannot make a sequence stratigraphic log because sequence stratigraphy is the interpretation part. In the field, what we do, we try to get the record of the rock types which comes in terms of the phases. So basically, we try to record the phases types. So all phases types constructing one vertical sedimentary log from one outcrop section that will represent that outcrop section, and accordingly we'll try to record all such outcrop sections in terms of the occurrences of the phases types. Rest part is the interpretation. So those phases types will be clubbed into phases association. Those associations will be correlated across all the outcrops, and then we'll go into the depositional systems followed by system strat. So this is the process commonly followed in practice. When we do sequence stratigraphic model, we follow this kind. So I hope is this clear to you? Okay, thank you. another question is there. So can you please explain the difference between relative and eustatic sea level change? Okay, this is more a kind of simple question or rather straightforward question. And we have already explained this in our lectures. There are separate lectures on relative sea level change and also on the eustatic sea level change. So basically, eustatic sea level change is the global sea level change. So globally, the sea level is rising or falling. And commonly, for measuring this global sea level change or rise, we commonly take this depth of water body with respect to the Earth center or commonly with respect to the ocean base, either of these two. But when we are talking about the relative sea level change, there we commonly look into individual basins. It is a local scale. And within this individual basin, we try to record the change in the sea level in that basin with respect to some reference point, commonly on the land. So some point on the land, with respect to that land point, you get change in the sea level within that basin. This is the relative sea level change. Global sea level change, it is irrespective of those land reference points. It is irrespective of those local scale variations. It is affected globally, affecting major oceans or large water bodies across the globe. And reasons are definitely different. So for eustatic change, we require much larger effects. So commonly we get either some tectonic causes. Tectonic means in terms of plate scale events like seafloor spreading, like the formation of supercontinents, like the breakup of the supercontinents. So these are the common factor which we commonly call as tectonoeustasy, the tectonic causes of global sea level changes. Also, we can have climatic causes, for example, formation of major glacier ice sheets on the continents, or maybe the deglaciation, that is the melting out of the glaciers from the continent. So those kind of effects, those kind of events adds or removes water from the oceans in global scale by changing the volume of water, and we get global sea level change. Commonly we call them as the eustatic sea level change, and when it is due to glaciers, it is the glacioclasty. On the other hand, if I look into the relative sea level scale, they are local phenomena where global sea level change can be one reason. If there is a global sea level rise, that can lead to local relative sea level rise. If there is a global sea level fall, it can lead to local sea level fall. At the same time, there can be local effects as well. Already we have discussed in our lecture on this particular aspect that what are the possible causes. Say, for example, glacio-isostatic rebound. For example, the gravitational attraction. For example, the mantle dynamic topography. For example, removal of karst topography, formation of karst topography and removal of material leading to the isostatic adjustment. For example, some fault activities which leads to some subsidence or uplift of the basin only, that particular basin. So in that way, several reasons are there that we have already discussed. So you can go back to that particular class, and there you can just go through those portions, and we hope it will be clear to you. And if even after that, if you have any confusion, we can come back to this and we can again discuss later on. So basically, this is the broad divisions between global sea level change and uh, relative sea level change. So the effect of relative sea level change is commonly less. Global sea level change is more. It is covering up larger areas in terms of its effect. It is more pronounced. So I hope this is clear to you.
अगर आप जानना चाहते हैं और तो क्वेश्चन इतना है नहीं, 1 2 3 पूछ लिया आप अनाउंस कर दीजिए वी आर टेकिंग क्वेरी इफ नो देन वी शुड sure.
Okay, so I think that no one else is joining. So if you have any more query, please ask. This particular forum is for discussion, for clearing your doubts. So by the time few more questions come, I can just tell you, this is also for those who have joined and those who have not joined as well. So basically in this particular course, first of all, I will thank you for joining this course or for opting for this particular course. And also I would expect that you are definitely uh, enjoying this particular course as we are gradually moving through this course. So already we have covered fifth week, 5 weeks are over. And through this 5 weeks time, we are gradually developing our concepts. So in the initial part, first week, second week, there it was mostly on the basics, very basics of stratigraphy, basics of sedimentology, because we there are persons from different backgrounds in this particular platform, and some basic concepts are required before we straightway jump into the sequence stratigraphy domain. Some basic understandings are required for everyone. So initial first week, second week courses were mostly uh, designed in that way so that you get that common platform, all of you get that common uh, ideas, concepts. And then from third week onward, we have started going into the further detail in terms of those concepts which are important for understanding the sequence stratigraphy. So that was in the third week and the fourth weeks. And now in the fifth week, we have now straightway entering into the sequence stratigraphy domain, where already we have introduced the concept of base level commutation. We have tried to understand what are the nature of fold line shift with respect to that base level and commutation, what are the stratal stacking patterns, and what are the resultant depositional products in terms of depositional system or system strats. Also, we have discussed about the terminations, which is one of the very important concept in sequence stratigraphy. Whenever we try to do sequence stratigraphy, the stratal termination patterns are very important to identify, distinguish the system strats, because each and every system strat, they will come up with some distinct stratal terminations. So now into the sixth week, which will be online by today or maybe by this weekend. So there you can see that we will be dealing with more sequence stratigraphic aspects in terms of the different sequence stratigraphic elements, introducing to different sequence stratigraphic elements in terms of the system strats, different types of surfaces. When I'm telling surfaces, that means the sequence stratigraphic surfaces or the system strat boundaries. And also we will be discussing about different types of sequence. And in consecutive classes, in the 7th week, 8th week, and then on, we will go into the detail of these individual sequence stratigraphic elements, where we will try to discuss about uh, the characters of different surfaces, how to identify them in the outcrops, how to identify them in the rock record, and what are the characteristic features of those surfaces, followed by discussion on the system strats, how they form, what are their nature in terms of stratal stacking pattern, and with respect to overall depositional pattern, starting from the continental side to marginal marine to shallow marine to deep basinal part, what are the manifestations in terms of different depositional environments and their products, the depositional systems? What are the manifestations under these different system strats? And finally, we will try to relate them with some application with respect to the occurrences of petroleum, occurrences of other deposits like coal or blizzard deposits, which are often we get associated, accumulated within this kind of sedimentary successions. So I hope that this journey will be helpful to you. Also, it will be enjoyable to you. And this forum is always there, available for any kind of discussions. Also, we have one forum for putting your queries. There you can write your query, which will immediately attend, will immediately revert back to you with a proper answer. So these are some messages that I wanted to give to all of you. Also, assignments are given to you. So I hope that assignments are okay and you are able to solve them. So again, if you have any query regarding the assignments, if you have any question or doubt about the assignments, any question within individual assignments, you can put it over here. We can discuss about that. So any question, any query, if you have right now, you can put it over here and discuss. Okay, so I think no one else is joining and no other questions are coming. So Mr. Jitendra Kumar, if you have any other questions, we can take that questions. You can put your query or we can, otherwise we can stop this session. Okay, so you do not have any questions. So thank you for joining, Mr. Kumar, and also thank you for joining all. So we'll end up this session over here, and I hope that you will enjoy this course. Thank you. Thank you, everyone.